Welcome to In 5 Minutes. In this video clip, we will discuss comparison between AM and FM. We have discussed a lot of things about AM and FM in detail. When it comes to writing down the comparison, we'll have to recall all those points and one by one differentiates AM and FM. Now one can write a lot of points on comparisons because AM and FM, they are very much different from each other in terms of definition and many other things. So let's one by one go through all the points that we can write in the comparison. The very first point will be nothing but the definition. As we know, in AM we vary the amplitude of carrier signal in proportion to instantaneous amplitude of modulating signal, keeping frequency and phase of carrier constant. In case of FM, we change the frequency of the carrier signal in proportion to instantaneous amplitude of modulating signal. This time we keep amplitude of the signal constant. If you remember, you can't keep phase constant. So we vary amplitude here and we vary frequency here. So that's first point, which is the definition. Second point will be the frequency domain representation, in which we show the sidebands. In case of AM, there are only two sidebands. So this is, let's say, carrier frequency FC, this is FC plus FM, and this is FC minus FM. So there are only two sidebands. And that too, if we go for single sideband transmission, we also remove one of the two sidebands and we get only one sideband. But in case of FM, we have multiple sidebands, so we have to show multiple sidebands. Theoretically, there are infinite number of sidebands, but if you remember, we use something called as Carson's rule, and we truncate the bandwidth and keep finite number of sidebands. So on this side, we can simply mention multiple number of sidebands. The next point we can write will be about mathematical expression. Mathematical expression for amplitude modulation. Now whenever we talk about AM, we will consider a double sideband full carrier because that's a conventional AM signal. So most of the points will be related to DSB-FC, and hence we may not mention it separately. In case of FM, whatever we write, we will mainly write it for wideband FM because narrowband FM otherwise is very much similar to AM in terms of number of sidebands and bandwidth, etc. So when we say there are multiple sidebands, and yes, all the sidebands will be around carrier frequency again, that's the case in wideband FM. So by default on FM side, we will write points for wideband FM. This you may not mention, it is comparison between AM and FM only. This is just for our understanding. So point number 3 will be nothing but mathematical expression. And in mathematical expression in double sideband full carrier, we know that it's nothing but Vc into 1 plus mu A cos of omega mt, and this will be multiplied by cos omega ct. So that's nothing but the expression of AM signal. Vc is the peak amplitude of carrier, mu A is the modulation index. On this side, if I write the expression of the FM signal, then if remember, it was nothing but Vc cos of omega ct plus 2 pi kf integration of m of tau d tau. Now this was obviously the generalized expression. What we are looking for is, here I'm using cosine signal as the modulating signal. So if I put cos here, this is from minus infinity to t, the integration of cos will become sine. So if you remember, the expression for sinusoidal modulating signal turns out to be Vc cos omega ct plus, here we will have mu f into sine omega ct. So that's the expression. You may not even mention this expression. This is a generalized expression. This is the expression when modulating signal is cos omega mt. Why sine appears here? Because we have integrated the cosine function, we get sine. This will be modulating frequency omega mt. So like mu A, here mu f is the modulation index. Please note that in our discussion we must have used small m to represent modulation index. I'm just using a notation of mu A in this particular case.